First, remember that the voltage is measured in parallel to the circuit or component to be checked. So we have to position the test leads between the ends of the circuit. Take a multimeter and select the DC voltage scale symbolized by the letter V with the straight lines. Choose a scale that is greater than or equal to the voltage expected in the circuit. If you don't know the exact voltage, start with the largest scale and adjust to smaller scales until you get a reading on the multimeter screen. Place the test leads between the ends of the component or circuit to be measured. This will give you the voltage value on the multimeter's display. For example, in this case, the measured value is just over 9 volts. This is the simple way to measure the DC voltage in a circuit. If you have any doubts about how to position the test tips, the previous video in this series covers this subject in detail. Check it out, the link is in the description. Now, if you are using an automatic scale multimeter, simply select the DC voltage magnitude and position the test leads at the ends of the circuit. The device itself will identify the scale automatically. This guy is incredible. DC voltage is so called because the positive and negative polarity of the source does not change. For example, this side of the battery will always be positive and the other side will always be negative. The voltage values may be variable, but the polarities are not. For example, we can have a constant value of 9 volts. Or variable values ranging from 0 to approximately 9 volts or any other value. The fact that the polarity doesn't change is what characterizes this type of graph as a current, or in this case, a direct voltage, but a pulsating direct voltage. One skill you need to have is the ability to identify whether the voltage to be measured is of the alternating or direct type so as not to make the wrong selection on the multimeter. And what happens if you reverse the measurements, set the selector to direct voltage and measure an alternating current? We'll take a look at it later in this video. Now let's test your understanding. Does this graph here represent direct or alternating voltage? Leave your answer in the comments so I can evaluate it. I'll select the best answers and give away a 100% scholarship on my electronics course from zero to project. We can also measure the voltage at other points in a circuit. For example, if we have a 9-volt battery and add a resistor, the voltage between the resistor's terminals will be the same as that of the source. This does not mean that the voltage is multiplying, but rather that the resistor is absorbing the voltage from the source, as it is the only passive component in the circuit. Now if we add another resistor of equal value to the circuit, the battery voltage will be divided equally between these two resistors. In this case, we have approximately 4.5 volts in each resistor. Remember that subscribing to the channel motivates us, and activating the bell provides you with free quality content. Don't miss out and do it now. Now let's understand the behavior of alternating voltage, abbreviated in AC, alternating current. In English, or CA, alternating current in Portuguese. This type of voltage reverses polarity over time. This change is represented graphically with negative values at the bottom of the graph, indicating that the polarity of the voltage has changed at this point. And with positive values at the top of the graph, again indicating the reversal of polarity in the circuit. In other words, the source has no fixed poles. In the next video in this series, we'll take a practical look at how to measure direct and alternating current using a multimeter.